Alright, welcome to Math 1332 video lesson, chapter 3, section 8. This is our last section for this chapter. Alright, section 8 deals with arguments and Euler diagrams. So it deals with arguments, and we're presenting them now using what are called Euler diagrams. Euler is a mathematician from the 1800s, early 1900s, and very, very important. I don't know if you ever see the constant e when we deal with logarithms and exponential equations. E is a constant. It's an irrational number. It goes 2.1, 2.14, 1.8, 5. It's a constant value. It's very important when it comes to quantum mechanics and physics and engineering. Let's remember, when we talked about valid arguments when all the premises were true, then it made the conclusion true as well. So when you do a truth table, the last column is always true. It's a tautology. An argument is invalid if it is not valid. So basically, is if it doesn't equal all. If there's at least one F on the last column, then it's not a valid statement. Euler diagrams are like Venn diagrams, except you don't have the universe defined. Remember, in Venn diagrams, we have the universe, the big rectangle. In Euler diagrams, we'll only use the circles. There are three predominant cases of Euler diagrams. And these deal with quantifiers. So whenever you have Euler's diagrams work only if you have quantified statements. If you have the word all in the description, for example, all P R Q, or if you have the word no or none, no P R Q, or if you have the word some. Some P R Q, which also means that some P are not Q. So if you ever have the word some or none or all, then that's when it's used Euler diagrams. These are quantified. In the all statement, you have one inside the other. So whatever the first one is goes inside the innermost circle. And the outermost circle, so all P are in Q. If you have the no statement, then you have two disjoint sentences or diagrams. They have nothing in common. And then if you have some, you have a P and a Q, and some of them are in common. Now, the way we use the Euler diagrams and to test validity is that if you could design a diagram where at least one possibility exists whether the conclusion is wrong, then it's invalid. It's called contrapositive. I mean, we would try to prove it wrong by showing you an example of something that's wrong. All right, so let's look at the homework assignments. So, use an Euler diagram to determine whether the argument is valid or invalid. All. So we have all. All dogs like food. So the outer one is food. The inner one is dogs. The next one, all pets like food. So pets go inside there, but can there be any overlapping of the dogs and pets? Yeah, can some dogs be pets? Yeah. But all pets love food. Or like food. So therefore, all dogs are pets. Well, here's an example where all dogs are not pets. And likewise here. So this is an invalid statement because I can make that diagram. Use an Euler diagram to determine whether the argument is valid or invalid. All birds have feathers. So one side. So the first one is birds. It goes inside here. And feathers. No mammal has feathers. Therefore, no mammals are birds. Can birds and mammals overlap if no mammals have feathers and all birds have feathers? So since there has to be disjoint, then no mammals are birds. True. So it's a valid statement. All horses whinny. So here are the horses. Here's Winnie. Some horses are brown. means other horses are not brown. Therefore, all brown horses whinny. So the brown horses, they're inside the whinny, so it's valid. Some investments are risky. Investments, risky. So some investments are risky. Real estate are investments. So we could do it like this. We could do it like this. Because here's your investments, here's risky, and real estate. It says real estate is an investment, so it has to be inside there. So investment, real estate, and some are risky. Therefore, real estates are risky. Well, I just drew an example where it's not risky. So this is invalid. All painters paint painters. All painters use brushes. So all painters brushes. Therefore, some painters are teachers. Oh, some people who use paint are teachers. So inside there, so here are the teachers. Some teachers use brushes. There's some people who paint are teachers. Yeah, it could be even bigger. It could be this way. So there's the teachers. But if you use paint, then you use brushes. And you use paint. Some people use paint are teachers, so yes, you have that one. Therefore, some painters are teachers. Let's look at this one. So there's the paint. And all painters, I'm going to call this A. All painters use brushes. Some people who use paint are teachers. Some people who use paint are teachers. Therefore, some painters are teachers. Are teachers painters? Invalid. Because I just drew an example there. That's it. Alright, that's chapter 1. Let's get do your homework, study, and let's get ready for your first chapter 1 test. Good luck.